Alright everyone, let's start about schema evolution now, which is basically the process of changing the structure of the schema over time without breaking existing producers or consumers. So we've seen that if we change a key or something related to a schema and the consumer is expecting a previous version or a new version, this can break the application side, of course, because they're expecting something that it's not receiving anymore. Okay, so exactly why do we need it? I think we're pretty much covered here, but it's very common in production or during a pipeline life cycle that the data format will constantly change. There will be new fields, there will be renamed attributes, everything like this. So we need to have a ability to create schema versions of those, because without those versioning, these changes that are happening can cause issues on the pipeline. So we've seen that the schema registry will prevent that by storing multiple versions of the same schema, and it enforces the capability rules, okay, compatibility rules. So how does that work? Whenever a new version of a schema is registered in the registry will compare it to the previous version. So if it violates any compatibility mode, the registration is rejected, or if that's not the case, it's saved and a new schema ID is assigned. Okay, so here we've seen as well this previously. If we have a version 1 where we'll have a name and age in the schema, uh, and the consumer is using this version 1, uh, whenever we change the version 1 for the version 2, where we add an email as an optional field, in this case, the consumer using the version 1 will still work because the new data produced will add an optional field, and the consumer using v1, it does not bother to not receive that information. But now, if the schema changes to a version 3, where it changes the name and adds a new mandatory field like email here, the consumer that uses the v1 does not work anymore, because the consumer uses the v1, it's expecting to have age and the name here. Now it's getting another key and another field which is mandatory. Okay, now let's talk to the compatibility modes. We'll work through two of them today. There's more, but the first one is backwards compatibility. So this ensures that newer readers, otherwise the consumers, or in other words the consumers, can update the schema and still consume events written by old writers, by previous producers. All right, and the forward compatibility says that it's going to ensure that newer writers or producers can produce events with an updated schema that still can be read by older readers, like older versions of the consumer. Okay, so here we have an illustration of the process going schema updating from v1, v2, v3. So v1 we have something, we add an optional field on the v2, and we remove a required field on v3, and we can say that v3 to v2 it's backward compatible, but v2 to v1 it's forward and backward compatible. So let's look at an example here first of backwards compatibility. So say we have a producer and we have a schema v1. We have here the type record, name user, and some fields over here. Okay, so producer is sending events using the v1, and consumer is reading the events also using the v1. Okay, now on the second scenario, there is a new optional field that was added with a default value. All right, so we do have here added the country field with default new. Producer is still sending the v1. That's okay because that's optional, and consumer is now using the v2 to read the value. Since this field is optional, the consumer still can read, so it works fine. All right, that's an example of backwards compatibility. Now when it breaks, for example, if v2 removes a field. So now we remove the email field here, so you can see we don't have it anymore, but producer is still producing to v1. Okay, producer is still producing with the v1. Now when consumer reads it using the v2, it doesn't know what to do with the email field that was written in the older data. All right, so when it tries to deserialize it, expecting to have that email field, it won't work anymore because it was deleted. Okay, now let's look at an example of forward compatibility. So we also have v1, same thing, everybody producing and consuming for a schema version v1. Okay, now we're going to add a field without the default value, so that's mandatory, and the producer starts sending events using that new field, so using the v2 here, so it keeps sending to v2. Now the old consumer schema doesn't know about the counter field, but it's possible that depending on how it's configured, it's using v1, it'll just ignore the new added field. Okay, now if the producer sends v2 to v2 and it's removing our required field, so now I'm removing email and email is required. Now the consumer that's using v1 does not receive the email, which is a required field, and thus it breaks. All right, so that's a bit about compatibility modes, and you'll see how this play out when we build our schema registry wrapper and we start using this in our code and setting up the clients for the producer and the consumers.